Well. All right. So yesterday we kind of hopefully jostled loose some memories of logs from Algebra 2. They are teaching logs in Algebra 2 right now, so about this time last year you also had this. And a heads up, we have a projected exit card on Monday. So if you haven't been doing the Delta Maths or they didn't go so well, that would be the thing to study from. It'll be like, hey, let's apply some of these properties and rules. Some of you are able to answer these without showing any work, which is great. But for those of us who can't, does anyone have a recommendation on how we can fight through solving these? Do you get in?
What I do is I look at what goes for the base.
Okay, so yesterday we worked on going from log to exponential and exponential to log. Logs equal exponents, and this guy down here is called the base. So Nate, how is that at all helpful? 8 to the something doesn't help me at all with 2 to the something.
2 to the third is 8, so it's 2 to the 3a.
8 is 2 to the third being raised to the a that multiplies. So Samara, where'd you go? Hi. So looking at it, I have 2 to the 3a equals 2 to the first. What's an equation that I can get out of that now that I'm looking at it? I have 2 to the this equals 2 to the that. What do I know about this and that? Okay. I have 2 to this equals 2 to that. Are they in exactly the same position? Don't they have to equal each other? So we're going to take them out and set them equal to each other. So what does this equal? 1/3. Yeah.
Do we have like a 4-function calculator on the test?
I mean, the 4-function calculators have pretty much always been available. They don't do a lot for you, but like those of you who are like 216 is what to what power, I have no idea. That would be helpful. So yeah, the 4 functions are usually available. There was a day that half of them were being borrowed by another teacher. That was the only day I was a little light. But Holiday, what's your recommendation of doing B? That was hard.
I really
Don't know? Nate?
Both of them are can be rooted to 3.
Okay, so he's like 27 is 3 times 3 times 3. 81 is 3 times 3 times 3 times 3. So
it's 3 to the 4x equals 2 to the 3rd.
okay, so he says it's 81 to the x equals 27, but really what he said was, well, 81 is 3 to the 4th, and 27 is not 2. 3 to the 3rd, raising the power to the power. So he says that exponent needs to equal this exponent, and if you look at his whiteboard, he says that fraction, that log is going to evaluate to be 3/4. Okay, Bailey, I know you weren't here yesterday, so let's see if you can remember. Do you remember how to go from log to exponent? Okay. Logs equal exponents. This thing here is called the base. So it's base to the exponent equals the number. So, Chloe, 72 to what power is 1? Don't know? Jonathan?
Is it 0?
didn't say it with a lot of confidence. Jasper, is it 0?
Yeah.
Yeah, oh,
Is that the word is better?
child development,
Oh, okay, okay.
0. So we said 2 days ago, anything to the 0 power is 0. Except 0 to the 0 in calculus, I can make it be, or sorry, is 1. In calculus, I can make it be other numbers. Okay, we didn't work with ln a lot. Beckham, what's the base for ln? It's not written. Is it 10? Dave, Dylan?
Is it log base E?
Okay, it's log base e. So if I don't say a number here at all, the implied base is 10. If I write ln, the implied base is e. So e to the x equals e to the fifth. So how does that resolve? What's the answer? Damn. 5. Kevin, you okay? You look
I'm good. I'm good.
like you didn't have enough coffee this morning. I did not. Okay, so again, homework's tonight on Delta Math to practice the logs. Yes?
Couldn't you also just cancel out the E's?
Okay. So yesterday we did problems like 12 to the log base 12. Those guys canceled and it's 5. And ln of e to the 5, well that's log base e to the 5. Dylan just said, don't we know that that's just going to be that? Yes, you do. So, but Dylan, if not everybody sees that, if you need to translate and be like, oh, that x is going to equal that, just to give you a strategy. Okay. Questions? Yesterday I asked you guys at the end of class to write down these properties. So, Natalie, can you see these at all back there? Okay. Any better? Okay, so if you don't have them written from yesterday, write them down. And then we'll talk about it. And if you do have them from yesterday, see if you can answer the one question that you can see at the very bottom. The question at the very bottom is, so try that problem if you've already got them written. Question? No. Yeah, take the pass. Okay, so couple things to point out. The bases have to match. Okay? And how to say this? And that number A has to be greater than 0 and not equal to 1. Okay, as I can't see. Why not 1? Well, if I said log base 1 of x equals, I'm going to pick a number. 2. Okay, that one works. But if I said, put the 2 here, when does 1 to the x equal 2? When does 1 to the power equal anything other than 1? It doesn't. Again, until you get to calculus. Then I can do funny things. But it's not really 1, it's a shade of 1. Okay, and I can't ever have put in a negative number for the logs. But, all right. Addition across logs is multiplication inside. Subtraction across logs is division inside. And then this little guy, this exponent can come out as a coefficient, or the coefficient can come in as an exponent. And then that bottom thing is a change of base. If any of you are into computer science stuff, I have a degree in computer science. I used to do a lot of things in base 2, base 8, base 16, all the time. But if you wanted this, not in base A, but base 2, all right. I wanted log base 2. The base goes in the basement, and the other number stays up top. Or if I wanted this in natural log, so in calculus I'm always going to natural log, it's an easier thing to manage. Again, base goes in the basement. I can change the base to anything I want. If you are like the Babylonians and they like base 60, cool, we can do that. So anyway, there's the rules. Using the rules above that are now scrolled off the top. Leah, looking at the notes, addition across logs of the same base, it's not written. What base is implied? 10. So addition across becomes what inside? What math operation?
Division.
Multiplication.
Or you said addition.
Addition
B,
across.
Sorry.
So what's inside?
5
Kevin, what
times
would be
2.
in?
7,
Multiply.
10.
10. Oh, and can I evaluate this now? What is it? 1. This is asking 10 to what power is 10 to the first? That's going to be a 1. Kevin, yeah? Sophia, log 400 minus log 4. They are the same base. Subtraction across becomes what inside? Looking at your notes that you just took, the subtraction is what math operation is inside?
400 times 4. Or negative.
Subtraction outside becomes division inside. And I don't know, I like to have little tricks to remember. This straight bar kind of becomes the fraction bar, maybe. So Jonathan, log 100. What is log 100? 2. 10 to what power is 100? Well, the whole thing comes out to 2. Yeah? There's so much fun and crazy excitement to do with logs, guys. Yeah?
When are we gonna start graphing these?
So, later. There's 2, like, rational functions. We did the graphing, like, talked about their properties and graphed them, and then we solved with them. Logs, like, wanted to see in the first place that they are inverses of exponentials to hopefully get you to understand that we can't put a 0 or a negative number in log. But now I kind of want to get you to understand the properties, and then we're going to do graphing in like a week. And then we're going to do crazy solving problems. I see them as fun. They're like little puzzles. Alicia's not sharing my excitement. It'll be fun. Yes. Okay. C. Does anybody know how we can get C? There's a couple ways to think of it.
Be 6 times the log 10.
So he says it would be 6 times log, I'm going to write it out this time, base 10 of 10. What is log base 10 of 10? Spencer, 10 to what power is 10 to what power is 10? 1. So what's 6 times 1?
6.
And Dylan's looking at it like, yo, didn't we just cover this? Can't I just go like that? Yes, Dylan, you can do that. Okay. And sorry, I taught honors for a long time. Couldn't help but put this one in there. Unwrap this like a present, because it's fun. Yeah.
Is it 1?
Okay. How'd you do that?
Log base 2, 32, isn't that like 5? I don't know, 5 to the power of 1 is 5.
So he did one thing at a time. He said, log base 2 of 32 is saying 2 to what power is 32? So that's 5. So he got rid of this whole thing and said log base 5 of 5. Well, that's 5 to what power is 5 to the first. So I don't know what he had to write down, but he said it all like, well, that's 5, so this is going to be 1. Jasper, yeah? So that one's the challenge question. Yay. Okay. All right. So, a reminder, log and exponent undo each other. So these things just are true. I'm missing the other piece, but- So log b to the log base b, whatever was in there pops out. And log base b of b to the whatever pops out. All right, so Kevin, maybe we'll leave that up. Kevin, what do you think? Log base 5 of 5, what's that gonna be?
X.
X, yes it is. Lucia, 2 to the log base 2 of x is going to be, okay, let's see, what pattern does it fit? Does it fit this pattern? Okay. Naomi, what's this one going to be? 3. And for whatever reason, I see this one as different. I still go back and think 7 to what power is 7 to the 3? 3. Okay, this one. Ella, what do you think for D? 3 log base 3 of 81. Which pattern does it fit? Does it fit this pattern or the first one? The first one. Does the base match? And the log is the only thing in between them, so whatever was there pops off. So what's this one going to be? 81. Okay. This is the first one with an extra step to it. Doesn't fit the pattern. This is base 2 and this is not. Anybody, can we convert 32 to base 2, Charles? What is it?
2 to the 5th.
2 to the 5th. So this is log base 2 of 2 to the 5th, then to the x, raising a power to a power? Do we add the numbers?
Multiply.
Multiply, okay. So do they match now? So Lisa, what's gonna come out? Let's look at the pattern, let's look at the pattern. Actually, do it this way. 2 to the a equals 2 to the 5x. What does it have to be? Five x. Tessa, what do you think about number 7 or F? It says 7 log base x of x to the k.
Well, once the x's cancel out, then it would be k on 7k.
Why, yes, it would. She said the log x and the x cancel out, the k comes off. Yes? Yep. So log and exponent undo each other. Yesterday, we had I don't know, something like that. And we couldn't solve it yesterday. I was able to say, I don't remember, maybe it was Jean Gideon, said 9 is 3 squared, so we got the bases the same. Okay, but it doesn't quite, there's something wrong. It doesn't exactly look like that. What's different?
There's a number in front of the log.
There's a number in the way. Well, stinky poop. The third rule that I asked you guys to write down, the ones that had the number out front, how can I get rid of that number? What does it do? Where does it go? Leah's actually looking back in her notes. Sophia, do you see? It comes in as an exponent on that guy. Okay, so 3 to the, now the 2 is moved. Ooh, now they match. Now I can cancel these out, and it's 20 squared. What's 20 times 20?
400.
400. Okay? All right. Okay. So how much more, I have a bunch of other things I need to show you. Do we need to practice more of these? Kevin says no. Well, Kevin, what's the answer to the first one?
4.
It is not
16,
4.
16.
16. Because 4 and log base 4, they go away, and it's 16. Okay, just real quick then. Arden, do you know what this one's going to be? Natural log. This is e to what power is e to the 5th? So what is x? It's going to be 5. Yes, no? No. Maybe 3. OS says log base 2 and the exponent cancel. And again, they had nothing in the way, nothing in between them. Okay, So, cool. This is, so the beginning of your Delta Math assignment is gonna be some things like that, like evaluate it, log base 2 of 4, 2 to what power is 4, 2. And then there's this kind of thing. All right. So I would not multiply those together. I want to make things to be what base? What do you think for this problem tomorrow? Base 2. So do you know what 8 is 2 to the power of what? 3. We've done this a couple times today. Allie, what's 32? 2 to the what? 5. Good. And Bailey, exponents. What's 2 to the 3rd times 2 to the 5th?
16 times 7.
No, don't go back to making them regular numbers. I want 2 to the something power. 2 to the 3rd times 2 to the 5th. Exponents when they're this same.
Oh, you add them?
So it's gonna be
2 to 8.
2 to the 8. There you go. There you go. Because oh my goodness, she was like trying to do
Yeah.
32 times 8. I'm like, oh, ouch, no. So now that we've finally gotten here, what log base 2 of 2 to the 8th, what's that going to pop out? That's 2 to what power equals 2 to the 8th? Do those guys match up exactly? What does the question mark have to equal?
8?
8.
Oh, so is it?
It's just 8.
Okay.
And not to be repetitive, this is like the 4th time it's come up today. ln of e to the 5th. 5. Yeah. Okay. Gross. Then there's these. Okay. So using the log rules that you supposedly wrote down yesterday, and if you didn't write them yesterday, I asked you to write them today. Spencer, are they the same base? Yeah, okay. And just like the other evaluating things, Gene Gideon said, there's a number in the way. Right here, this number's in the way. I think it was, I don't remember who told me. How do I get rid of that number out front? I want to move it. You see, what do I do?
Oh, wait, which 5?
Yeah, the 5. I want this 5 to not be there. How did we manage that? Looking at the properties were addition across became multiplication inside, subtraction across became division inside, so that minus sign kind of looks like the fraction. Well, and then the number out front came in as an exponent. So I'm going to pop that up here. Got to bring the exponent in first. And now it looks like this pattern of log this plus log that, and she said now we want to multiply it. So this is going to be log base 2 that. Yeah? Okay. All right, and I put my rules under these guys. So I gotta erase them. Natalie, how do we wanna attack this second problem here? Should we do parentheses first, or should we? Parentheses first, great idea. Are there any numbers hanging out in front of the logs that I need to deal with, or can I just, Naomi says no. So, plus across logs of the same base is what inside?
Multiplication.
Gene Gideon says multiplication, so what's gonna be put inside? AB. Natalie, your voice has changed. This stuff in the front is still there. So Ally, now I have log, and a subtraction. What does it become?
Log 5x minus 2b.
Log base 5 of x divided by AB. Yeah? Arden, question? Or you just can't see because people are in the way? Okay. So, evaluating logs, just numbers. Log base 10 of 100. Well, 10 to what power is 100? 100 is 10 squared, so 10 to what power, that would be a 2. Need to be kind of up on that, and here's our log rules. So some of the homework is squish it together, and some of it is pull it apart. Ella, multiplication inside becomes what operation when we pull it apart? Addition. How many things are being multiplied? The 9 and the x. So I'm gonna need 2 things to split it up. Can I evaluate, can I get a number out of any of those? Naomi's saying yes, Jean Gideon saying yes, Boaz is kind of nodding his head yes. What number comes out of the first one? Tim says 2. 3 to what power is 9? 2. Okay, and Tim asked, when are we getting to graphing? So Tim, one that like the county used to ask things like this, like, oh, what kind of vertical shift is going on with this function? And they're expecting you to pull it apart and be like, okay, we'll get to it. We actually have graphed log base 3 of x already. Once we can graph that, this one is gonna be just move it up to. So we need a few of these skills before we can do the other things. Oh my goodness, so many pieces. Spencer, how many things are in this lumpy dude in here?
2.
Oh, okay, you could see it as 2. I see it as, I got a 5, I got an a squared, I got a b, and I got a c. I'm gonna have 4 different stupid lumps. And I don't have a lot of control over the kinds of questions that Delta Math asks. I try to not have them have 4 pieces to them, but that's not exactly an option they let me turn off. So, step 1, I see a division inside, so I make it a subtraction. Step 2, I see 3 lumps multiplied. So I'm going to pull those multiplied things apart. Oh my goodness. And you guys do not like the writing of all of these things. I apologize. And there's still 2 more things to do. Can I do anything with that? Log base 5 of 5. Gideon says yes. Dylan, what is it?
Log base 5 of 5.
Uh-huh.
1.
1. 5 to what power is 5 to the first? 1. Okay. This thing, can I do anything else to it? Jonathan, what is it? Okay, I wrote that wrong, sorry. And this one, it's kind of done. that's expanded. So there'll be some expanded condensed ones on the Delta Math. For those of you who want to just type it, the Delta Math, I believe, has a thing that you can click the button. I don't know about you, but taking my hand off the keyboard and getting to the button is a pain. So if you type in log and underscore, like that underbar, it'll move you down and you can just type in the base if you want to. But do we still have time? It's Friday schedule, so shorter or longer. You have like 6 minutes, you can start the Delta Math homework. And if you have